Okay, for the rusting portion, there are a few things you need to know. Okay, first, of course, is what is rust. Rust is actually hydrated iron trioxide. Okay, so rusting, technically speaking, is only for iron. Okay, but nowadays, actually for O-level, sometimes other metal, they also use the word rust. Okay, but rust itself is actually hydrated iron trioxide, not iron 2, iron trioxide. Then it's hydrated means you have water crystallization, so it's dot something H2O. Okay, so the condition needed for rusting, there are two. You must have presence of oxygen and water. You must have presence of oxygen and water. Okay, lack of any one of those will not cause rusting. So if you have oxygen, no water, the iron can oxidize, but it cannot form rust. Okay, if you have water, no oxygen, of course, the iron won't react at all. Okay, the iron trioxide, hydrated iron trioxide is rust is more, we need to learn is because it actually it can flake off the surface. It can reduce the strength of iron. Okay, if it's just iron trioxide without the water crystallization, it's not called rust yet. Okay, it's not in danger of so-called damaging the strength of the iron. Okay, right. So besides knowing the condition needed for rusting, you also have to know what can enhance the rate of rusting. That means what can make rusting faster. Sometimes they tell you, right? So besides oxygen and water, what can make rusting faster is presence of mobile ions. So for example, if your iron, right, is deep in pure water, it actually will rust slower than if you dip or present it in the presence of salt solution, right, or acidic solution or alkaline solution, because the presence of the ions can actually cause some electrolytic reaction with the iron. That one you don't need to learn too details, just need to know if you have presence of mobile ions, right, whether it's salt solution, any salt solution, acids or alkaline, it can enhance the rate of rusting of the iron, make iron rust faster. Okay, so these are a few things. The last but not least, which is more important, is actually the rust prevention. How do we prevent rusting? Mainly two methods. One is called coating prevention. Coating prevention is basically to prevent iron in the steel or iron alone from contact with oxygen and water in the surrounding. So basically you cover the iron up. Okay, you hide the iron inside something that is typically impermeable, right, to prevent the oxygen and water from reaching the iron. So things like painting, oiling, greasing, or electroplating with a less reactive metal, like tin plating, silver plating, copper plating, all these are called coating prevention. However, the bad thing about coating prevention is you have to take note, and sometimes they ask, usually, is if the coat is removed or coat is damaged, right, due to wear and tear, the exposed iron or exposed steel will still rust. Okay, that means if the iron is exposed to the surrounding, it will still rust. Okay, it's not prevented. So you have to keep painting or oiling all these things to prevent it from rusting. Okay, right. The other method is called sacrificial protection, which are maybe not so familiar to you all, is you put a more reactive metal with iron. That means a metal that's more reactive than iron together with iron. But cannot put those highly reactive ones. Potassium, sodium, calcium, all those cannot, because if you put with iron, right, if you put out in the nature, rain come, all these three metals all react immediately, vigorously. Right, so the iron will still be exposed in a minute of a matter of seconds, right? So it's not economically effective or sensible basically to put these metals with iron. Okay, so usually it's magnesium onwards, then we put with iron. Okay, but the metal must be more reactive than iron, cannot be less reactive. If less reactive, the iron will still rust and rust even faster. Okay, how it works in general speaking is the more reactive metal will corrode in place of the less reactive metal, which in this case is iron. So instead of iron rust, the more reactive metal will corrode in this place. That's why it's called sacrificial protection. You sacrifice the more reactive metal to protect the iron. Okay, why we need to protect iron? Because iron is what supports the structure of this. Okay, right. The advantage of this method is you don't need to cover the whole piece of iron. Okay, you can just put a few pieces, a few blocks at intervals, then can protect a certain area or certain length. Okay, example of sacrificial protection will be putting magnesium blocks or zinc galvanizing. Zinc galvanizing is actually zinc plating also, but for zinc we use the word galvanizing. So if you see the word galvanizing, it's referring to zinc. Okay, magnesium blocks is put blocks at intervals or at spaces, okay, certain spacing to protect iron. Okay, like for example, water pipe, sometimes along the pipe, they will put magnesium blocks. And the good thing about this sacrificial protection is you don't need to actually come directly in contact. Sometimes they just put wires connecting, also can protect. It's electrical wire or metal wires, wiring. Okay, right. Generally speaking, how it works is like this on. Whenever you have a metal with iron, right? If I have a more reactive metal like magnesium, okay, what happens is the magnesium being more reactive than iron, it actually corrode. Okay, it actually gives electrons away to the iron, because remember, metal want to lose electron to achieve the noble gas structure. So the more reactive metal basically will be able to lose electron to the less reactive. If they are alone, they will lose electron to the oxygen in the air to form oxide. But if they are contact with another metal, of course they will prefer to lose electron to the metal, because metals are good conductor of electricity, right? Electron is electricity. So what happens is the iron, right? The magnesium, more reactive magnesium will lose electron to iron. By doing this, it actually protects the iron from rusting. Why? Because when the atom of the iron want to rust, it actually have to lose electron, right? Because iron, to become iron 3, the iron have to lose 3 electrons to become iron 3 ions, right? So you need to lose electron. So imagine it's like this atom lose electron, then the electron from the magnesium actually go in and cover it up, right? Something like that. So it actually prevent the iron from oxidizing, and so prevent it from rusting. Okay, that's the idea. It's like you want to become bankrupt, you keep losing money, and someone keep giving you money, something like that. Okay, so that's how it works. Right, so over time, the more reactive metal, of course, will become smaller and smaller because it become ions. So physically, we see it like dissolving. So after some time, if too small, we have to replace it. Okay, so it's being sacrificed. That's why you call it sacrificial protection. The more reactive metal is called a sacrifice metal. Okay.